This video provides easy-to-follow instructions for you to create this pipe tee using Onshape. Click below in the video description. Here you will find links to all of the resources you need to complete this project. First, there is a link for a PDF instruction sheet. Click this link and open the project drawings and specifications in a new browser tab. Next, if you don't have an Onshape account, use one of these links to create a free account at the Onshape website. Last, there are links for each of the segments of this video. The video instruction is organized into 5 segments. In Segment 1, you will read the engineering drawings. Segment 2 will establish the design intent. In Segment 3, you will create the part model using Onshape. Next, you will check the accuracy of your model by checking its mass properties. Last, you will check the design intent by making changes to the model to see if it will update correctly. Now you are ready to begin the project. In this segment, we'll read the engineering drawing for this pipe tee. Let's start by identifying the views provided in the drawings. First, there is an isometric view showing the pipe tee as a 3-dimensional pictorial. Next, 3 orthographic views. On the bottom left is a front section view. Projected and aligned to the right of the front view is a right side view. Projected and aligned above the right side view is a top view. The front view is shown as a section view. This makes visible the interior features, the wall thickness, and the transitions between the outer flanges and the pipe. The cutting plane line in the right view shows the location and direction of the section view. The detail view shows an enlarged section view of the transition from the outer flange to inner pipe. When planning a parametric model, we first need to identify its basic shapes and included features. The pipe is circular and concentric along its midline. All of the openings have a consistent diameter and depth. All of the walls have a uniform thickness. Next, we'll look at the dimensions and notes. First, the dimensions are in decimal inches. The flanges have an outside diameter of 4 inches and an inside diameter of 3.75 inches. This results in a wall thickness of 1/8 or 0.125 inches. The flanges have an outside length of 2 inches. The pipe has an outside diameter of 3.500 inches and an inside diameter of 3.250 inches. This results again in a wall thickness of 1/8 or 0.125 inches. The pipe has a height of 5 inches between the outer flanges. The transition pipe also has an outside diameter of 3.5 inches and a wall thickness of 1/8 inch or 0.125 inches. The center of the transition pipe is 3 inches above the flange edge. The pipe transition follows an arc that has a radius of 2.75 inches. All inner edges have a chamfer of 1/16 or 0.0625 inches. The outside junction of the pipe and the flange has a fillet of 1/8 or 0.125 inches. The material from the Onshape material library is PC/ABS plastic with a density of 0.04. Next, let's establish our design intent. To start, we need to identify any features that might be changed during the design process. For this design, we may need to increase the length of the pipe. Next, we should identify the features that should remain unchanged when it is revised. In this case, the outside and inside diameters will remain the same. The length of the end flanges will not be changed. The wall thickness will remain the same. The location of the center of the transition will remain the same relative to the vertical ends. So how should we expect the model to behave when it is changed? We should be able to change the length, and the rest of the features should remain the same, including the center location of the transition along its relative length. Before we model the part in Onshape, let's preview the steps in the modeling process. First, from the drawing, we will identify the profile we will use for the base sketch. In this project, we will use the top view to create the base sketch. Sketch 1 will define the circular profile of the pipe without the flanges. This will be placed on the top sketch plane with the origin at the center. Extrude 1 will create a solid cylinder the height of the pipe. This is the base feature. Sketch 2 will define the center of the sweep path of the circular transition. Plane 1 will create a sketch plane for Sketch 3. Sketch 3 will define the size and location of the transition. Sweep 1 will create a solid of the transition. Sketch 4 will define the outside size of the top flange. Extrude 2 will create a solid of the top flange. Sketch 5 will define the outside size of the bottom flange. Extrude 3 will create a solid of the bottom flange. Sketch 6 will define the outside size of the transition flange. Extrude 4 will create a solid of the transition flange. Shell 1 will remove material, creating a uniform wall thickness. Chamfer 1 will remove the sharp corners where the pipe meets the flanges. Chamfer 2 will remove the sharp corners on the inside edges of the flanges. Fillet 1 rounds corners on the inside and outside of the pipe. This results in our finished pipe tee. Now let's get started in creating the pipe tee. I have started a new Onshape document and named it pipe tee. The workspace units are set to inches and the mass is set to pounds. Our design intent defined one parameter that we may need to change later. This was the pipe length. Let's set this as a variable. On the right, click on the button for the variable table. Add a variable named length and set the value at 5 inches. Close the table. Notice on the left, the variable has been added to the top of the feature list. Start a new sketch and choose the top sketch plane. Use N from the keyboard to view the sketch normal to the screen. Use P on the keyboard to turn off the visibility of the sketch planes. From the sketch toolbar, click on the center point circle. Click coincident to the origin for the center. Set the diameter at 3.5 for the outside of the pipe. This looks right. Use the green check to close. Next, click on Extrude on the feature toolbar. This will be a new feature. For the sketch region, click on Sketch 1. Click on the depth and enter hashtag from the keyboard. Choose length from the variable pop-up. Use Enter to set the depth value. The direction should be above the sketch plane. This looks good. Use the green check to close. Now, we can use a sketch to define the path for the transition. Let's start with a section view. Click on the camera and render options and select section at the bottom. For the section plane, click on the front plane. Start a new sketch. Choose the front plane. Use N on the keyboard to view normal. We can use a construction line to find the center of the arc. Click on Line and Construction on the toolbar. Hover on the origin and move the cursor up vertical and click to start the line. Drag the line horizontal to the right and double-click to end. Enter 2.75 for the length. From the toolbar, click on Center Point Arc. Click coincident to the end of the line for the center. Click coincident to the other end to start the arc. Stretch the arc up until it is vertical to the center and click to end. Click on the Dimension tool and set the distance between the end of the arc to the origin. This is the center of the transition opening and the distance is 3 inches, which is just above the center of the pipe. From the design intent, we know that we want the center point to maintain its relative location if we change the length of the pipe. Let's use a formula to set this relative location so that if we change the length of the pipe, the center point can update automatically. Double-click on this dimension to edit it. Use the hashtag from the keyboard and choose length from the variables. Enter an asterisk for multiply and then enter 3/5. Use Enter to calculate the dimension. Now, if we change the length, the location of the center point will update to be 3/5 of the new length value. This will maintain the location of the transition relative to the new length. Let's try it. Open the variable table on the right. Double-click on the length variable. Change its value to 8 and use Enter to update. We can see that the arc location updates using the formula. Undo the change. Close the variable table and use the green check to accept the sketch. Right-click and turn off the section view. Now we will need a sketch plane for sketch 3 to define the size and location of the transition pipe. From the feature toolbar, click on Plane to create a new plane. For the plane construction method, choose Plane Point from the drop-down menu. To set the plane location, click on the end point of the arc. For the plane orientation, click on the right plane to set the new plane parallel. This looks right. Use the green check to close. We can now use a sketch to define the size and location of the transition pipe. Start a new sketch and click on our new plane for the sketch plane. Use N on the keyboard to view normal. From the sketch toolbar, choose Center Point Circle. Click coincident to the point at the end of the arc. Set the diameter to 3.5, same as the vertical pipe. This looks good. Use the green check to close. We will use a sweep to create the transition. Click on Sweep on the feature toolbar. We will add to the existing part. For the sketch region, click on Circle in Sketch 3. For the sweep path, click on the arc from Sketch 2. Check the box Merge with All. This looks like what we want. Use the green check to close. To add the flanges, we can use a sketch and then extrude to add the material. Let's start with the top flange. Start a new sketch. Click on the top face for the sketch plane. Use N to view normal to the sketch plane. Click on Center Point Circle from the Sketch toolbar. Click Concentric to the origin and draw the circle. Enter 4 inches for the diameter. Use the green check to close. Right-click and choose Isometric. Choose Extrude from the feature toolbar. We will add. For the sketch region, click on Sketch 4. For the depth, enter 2 inches. Use the green check to close. Repeat this same process to add the flanges to the bottom and the transition. This looks good. We will now use shell to hollow out the part, creating a uniform material thickness throughout. Click on Shell on the feature toolbar. For the shell thickness, enter 0.125 or 1/8 of an inch. For the faces to remove, click on the faces of each flange. This looks good. Use the green check to close. A chamfer will be used to remove the sharp corners on the inside edges of the flanges. From the feature toolbar, click on Chamfer. Choose Equal Distance from the chamfer type dropdown. Set the distance at 1/16 inch or 0.063. Click on the inside edges on the flange opening and at the transition from the flange to the pipe. Apply this to all 3 flange openings. This looks right. Use the green check to close. Last, we will use a fillet to round the transitions on the outside of the pipe. From the feature toolbar, click on Fillet. Set the radius at 1/8 inch or 0.125 inches. On the outside, click on the corner where the flange meets the pipe. Select all 3 instances. Also select the edge where the curved transition meets the vertical pipe. This looks right. Use the green check to close. The pipe tee is now complete. In this segment, we'll check the accuracy of the model by checking its mass properties. To check the model, the mass units should be set to pounds and the material set to PC. ABS. If the size and shape of your model was completed accurately, the mass should be 0.698 pounds. Let's look at this process step by step. First, open the document that contains the model of the pipe tee. Next, check the workspace units. And make sure that mass was set to pounds. Next, set the material to PC. ABS. Go to the part in the parts list. Right-click and choose Assign Material. In this case, we're searching for PC. ABS. With a density of 0.04. Click to select it. Next, go down to the lower right corner and click on the Display Mass Properties button. When the dialog box opens, click on the part, and the display shows a mass of 0.698 pounds. If this was your result, then your part is accurate and matches the specifications. If not, we can troubleshoot to locate the sketch or feature that has an error. First, locate the rollback bar in the feature list. Move the rollback bar up to just below Extrude 1. The mass now reads 1.912 pounds. If you have an error here, examine Sketch 1 and Extrude 1. Now move the rollback bar down to below Sweep 1. The mass is now 2.434 pounds. If you have an error here, examine Sketch 2 and Sketch 3. Now move the rollback bar down to below Extrude 2. The mass is now 3.433 pounds. If you have an error here, examine Sketch 4 and Extrude 2. Now move the rollback bar down to below extrude 3. The mass is now 4.432 pounds. If you have an error here, examine sketch 5 and extrude 3. Next, move the rollback bar down to below extrude 4. The mass is now 5.431 pounds. If you have an error here, examine sketch 6 and extrude 4. Next, move the rollback bar down to below shell 1. The mass is now 0.698 pounds. If you have an error here, examine the specifications used for shell 1. Now move the rollback bar to below chamfer 1. The mass is now 0.693 pounds. If you have an error here, examine chamfer 1. Now move the rollback bar to the end. Again, the mass should be 0.698 pounds. If you have an error here, examine the specifications used for fillet 1. You should now have found and corrected any errors, and your part is accurate to the specifications. In this segment, we will make some revisions to the part and check if our design intent has been applied correctly. We will start by reading the revision directions from the project instruction sheet. First, change the variable for the pipe length from 5 inches to 7 inches. Verify that the part updates without errors. Second, open sketch 2 and check that distance from the bottom of the pipe segment to the center of the transition arc has updated to 4.2 inches. Last, check the mass properties of the revised part. The new mass should be 0.803 pounds. Thank you for watching. If you enjoyed this video, look for more projects at cadvideotutor.com. Also, hit the like or subscribe button. If you have a question, leave a comment.